welcome everybody to this morning's Tech Talk. I don't do too many of these anymore, but when I do, it's an absolute pleasure. So I'm pleased to be here. I actually I prepared this Tech Talk for today, but I had it ready for a plumbers evening in the Western Cape, for an IOPSA plumbers evening, just an online, I also presented it there. So if you have seen this before, it means that you're an active member of Western Cape IOPSA. So well done to that. But we're going to talk about ducts in residential class buildings, and specifically, and of course, as this little webinar goes on, you will realize that we're talking about the lack often of ducts, because that is exactly, the requirement is one thing, but the fact is that ducts are so often not part of a design of a building. We, all of us at some point or another, within our plumbing careers, if you are a plumber, will require ducts, where you will lament the fact that the duct is not there, or you will be grateful that it is there. Because how often are ducts and the requirements for ducts overlooked in the plans and the design of a building? I mean, how often have we been asked to put our stacks, our sewer stacks and waste pipes, just build it in the wall or chase it in the wall? I'm not a structural engineer, but I'm pretty sure that, first of all, it's not too good and a healthier situation for the structural stability of the wall. But second of all, it completely contradicts what the requirements are for access to pipes and so on and so forth. And we'll see, I'm hoping to unpack it as we go along. You'll see that the standards, one standard in particular, 10252/2, which of course is the drainage installation standard, and part P, which is the also 10400 part B, they all talk about ducts, and there are specific requirements about ducts. And I'm hoping to shed some light on the fact that you can't just get away with asking a plumber to put a pipe in a wall anymore. Well, it's been happening for decades, hasn't it? But I mean, we must, as plumbers, we need to start waking up and taking a bit of responsibility and saying, hey, Mr. Designer, hey, Mr. Architect, this is not right. You can't ask me to do this. These are the requirements, and let's try and change this design a little bit and have these discussions. Okay, so I've already said that they overlook ducts. When I say they, I'm throwing a blanket over the powers that be, the powers that make the decisions when a building goes up, whether that's the architect, the designer, a developer, or the owners associations, or whatever the case may be. They make the decisions when it goes up, and very often is the case they don't want to see pipes, without recognizing or realizing the ramifications of what they're saying. They just say, well, we don't want to see any pipes. We don't want to see a vent. We don't want to see this, that, the next thing. And that just puts a spanner in the works in terms of what the plumber is now expected to do. So the plumber would then say, okay, well, where is the space for me to put my stacks in? No, you must put it in the walls. And I mean, that's just ridiculous. So this is what we're faced with on a regular basis. And because of that, we have to find very clever places to put pipes. Now, have a look at these pictures here. This is a brand new development that you can see the date and time of my pictures. They're not so long ago. It's a brand spanking new development. And this is a geyser in a cupboard, in a bedroom, if I'm not mistaken, as you can see there on the right-hand side. And we're not even talking about the legality of the geyser, but have a look at where the sewer stack comes down. It's the wrong type of pipe. All the junctions are inaccessible in terms, there's no rotting eyes or anything like that. Well, you can't have them there, because how do you access it without spilling and messing cupboards? So here is a sewer line and waste line that is in a bedroom cupboard. Now, and it's not one story, it's 6-7 floors, okay? Now, we got to understand the nature of a sewer line. A PVC stack is not a cast iron stack, or at least a stainless steel threaded 110 millimeter threaded fitting. it's going to leak by its very nature. At some point in its life, it is going to leak. Those joints and fittings, yes, they are robust, but there is an assumption at some point that there is going to be leaks because they are not seriously robust fittings. Now, to place it or to ask a plumber to place it, a stack like this in a cupboard is just irresponsible. It's absolutely irresponsible. So this is the sort of things that we are often asked to do and forced to do. Now, what do the standards say? So let's just go through and see what the standards actually require. So we're talking about SANS 10252-2 and section 6.7.3. It talks about ductwork, and it says the following considerations must be taken into account, among others. 6734 it says, and this is key, where a discharge pipe is located in any building and it is desired that such a pipe be enclosed, it shall be enclosed within a duct. There it is. That is your, that sentence, it says it all. It doesn't say it shall be enclosed within a wall or you know, it says it shall be enclosed within a duct. And it says the duct shall either be of a size and shape that any person can readily enter it and work in it. That's key. Or it shall be provided with covers that can be readily removed to enable access to be gained to all junctions, bends, and cleaning eyes. So either it's big enough for you to get into and work in, or it is it allows access to every single junction, every single bend, every single rodding eye in that entire stack. Now, again, you can see these pictures. The one on the left, you might see more, a couple more pictures of that of the same installation further down the line. This is, I'm standing, that's my hand on resting on a little, as you can see, an aperture with a little door. You can't even fit your head in there to see what's happening. Never mind work on that stack. You'll see other pictures a little bit later. But this is, I'm standing inside of a passage, a residential passage. You walk into the building, you have rooms on your left and right, and you got one, two, I think it's 3 stories, and you have these stacks running down every second room. So there's probably about 15 or 16 of these stacks and 16 of these little access hatches inside a residential corridor. The stacks terminate at floor level on the ground floor, and any leakage, anything, it just sits there. It's inside the building. It's not even outside. So this is the kind of allowances that are being made for plumbers, and it's not the plumber's fault when he gets to a building and it looks like this. You know what I'm saying? So you have to be able to get into the stack and or access everything in order to work on it comfortably. You shouldn't need to break down structure in order to access junctions and bends, etc. Carrying on, it says the removal of any component of the building for purpose of gaining access to any pipe shall not endanger the structural stability of the building. Well, that's clear enough. So you don't want to have to go through a structural element in order to access a pipe, which is clear. But it's already told us that things must be accessible. All right, with covers that allow ready access. And then it says a means shall be provided inside the duct to direct the discharge of any released liquid or matter from the area inside the duct to a point where it is preferably is readily detectable should any leak develop inside such a duct. So there is almost an assumption that leaks will occur from sewer stacks. Sewer and waste stacks have to be worked on and repaired. And when you do things like this, it happened to me so many times. You have to repair a piece of 110 mil stack. You try and tell 3 floors above you, please don't flush for the next 3 hours. It's not going to happen. They're going to flush. Okay. So be that as it may, a sewer stack equals there's going to be release of matter, of sewage, of water, of some kind of a discharge, and that discharge has to go somewhere. You can't just allow it to land up in somebody's walkway. So the bottom of the stack of the duct, I beg your pardon, has to have a means of discharging or allowing the waste to run away, and it needs to be detectable. So if a leak develops unseen in a duct, you want to be able to, ideally, I suppose, walk past the thing and see a bit of a trickle somewhere or a discharge, and it needs to be visible. Now, have a look at those pics. It's simply not the case. So you've got a terminated duct, which is just the end. It's just the floor. That, by the way, is the bottom of one of those ducts that I was talking about in the previous slide. It just terminates on the floor. Not only that, but have a look at the waste pipes. I'm talking about the right-hand side picture, how they join the stack, and how do I maintain that situation? We're not even talking today about the requirements of a single stack system and how to join waste pipes to a single stack, and how it's allowed to be done and how it's not allowed to be done. But I can tell you it's not allowed to be done like that. First of all, there's no access. And how do I get to that? The bottom of the picture is, if the camera is sort of half upside down, but the bottom of the picture is that it's a sort of a drywall. I think it's a fiber cement cladding, which is going to have to be broken out in order to access that. And then you can't even access it because there's no rodding eyes, at least inspection eyes on those bends. So you're going to have to cut the pipe. And there's lots of problems there, and nothing's detectable in terms of leakage. Well, it is, but it'll just come onto the floor, but it's not safely discharged. And so this is a continuous struggle. This is more of the same development. I just found it fantastic that a single development could have this much non-compliance in terms of ductwork and so on. So the standards carry on. They talk about when they say, okay, any part of the pipe may be built into brickwork or concrete, provided that the interior of the part is rendered readily accessible for cleaning and maintenance. Now, I don't interpret that as being a day pass to build a stack into a wall. Your discharge pipe must be, or the stack must be, accessible in terms of maintenance, and you cannot have like it says right in the beginning, if the discharge pipe is intended to be enclosed within a building, it must be enclosed within a duct. What it's saying here is that if you need to pass pipes through an element such as a concrete floor or a brick wall, passing through is different than being totally enclosed by. So it says when you pass through a wall or whatever, make sure that there is a means for you to get inside that pipe from a rodding eye, an access point at some location, without you having to chop and break a wall to get to that pipe. So that's what it's trying to prevent. And then it starts to talk about its vicinity to other services, in particular hot water pipes. So hot water pipes, just before I read what it says there, I'm sure you've read it already. Hot water pipes have an ambient heat which they sort of radiate out, and waste pipes suffer a thing called dry out. And what happens when a waste pipe or a discharge pipe, or a stack for that matter, dries out, there is actually, I don't know how many of you, if you were at the Western Cape, a couple of Western Cape IOPSA meetings, Kurt Vermaak did a talk on biofilm. And biofilm is something that exists in waste pipes and in sewage pipes. And it is, as the name suggests, it's a film of matter which sits on the inside of waste pipes, of discharge pipes. And it can get quite intense. And I mean, by that, I mean, it can actually get quite, quite a lot of it. And if it's an unhealthy system, that biofilm itself can start causing problems. But more often, what happens is, in a dry out situation, when a pipe is allowed to dry out, that biofilm flakes, it crusts and it flakes and it becomes hard, and it sits on the inside of the pipe and it becomes this hard obstruction. And if it happens more than, then stuff starts flowing again, more biofilm is present and it dries out again. And if this happens a few times, what starts to happen is that pipe becomes very prone to blockages because you are slowly and systematically blocking it. So dry out is not a favorable condition to have within a waste pipe or a sewage pipe. So therefore, they specifically say to you, please don't install these waste pipes within a certain vicinity of hot water pipes because of the temperature. And so it must be at least 75 millimeters away from any hot water pipe if that hot water pipe is insulated. And if it's not insulated, it's got to be 150 millimeters away. So that's another, they wouldn't put it in the standards if it wasn't a real concern. It doesn't sound like a major, consideration or a major train smash, but who am I to judge what the standards say? And dry out will perpetuate the blockage of a system much quicker than normal. So hence the need for that. So have a look at these pictures and ask yourself whether or not the guy has, whether that has been adhered to. And in fact, within this duct, there is sufficient space to adhere to that. But this is sadly not the case in these pictures. Again, you can see those waste pipes at the bottom there, joining the stack in, shall we say, unconventional means. Okay. So another thing to consider is that for us to be able to comply with this installation standards of drainage, and I'm not going to go into drainage requirements now because that's not what this tech talk is about, but there are certain things that within the requirements of particularly a one pipe system that almost require ducts. It requires good access to the pipes, and it's almost, you can say, well, if you want me to comply with 10252 in terms of access and in terms of the installation standards, then you have to provide me with adequate space, because I can't comply. There are certain things that I can't comply with if you just ask me to put it in a wall. Okay. Examples of this are connection restrictions. And I just want to touch on connection restrictions because that's a prime example. I'm not going to go, as I say, into detail of installation instructions for sewers and wastes, but there are connection restrictions within a single stack system or one pipe system. By the way, a one pipe system means that a single stack or a single pipe is used as the discharge stack as well as the ventilation stack. So as opposed to a two pipe system, which will have a dedicated ventilation stack and a dedicated discharge stack. So most systems are one pipe systems, and there are connection restrictions. So as you can see in these little pictures here, there are hatched areas or areas within a stack within which you may not make connections. And the reason is because as water changes direction around a bend, for example, this one at the bottom, the flow of the water changes and the shape of the water within that pipe changes, and there may well be areas within that hatched area where the pipe is completely filled with water. So you've disrupted the flow. It used to be nice and laminar or sitting on the sides, and the air could pass backwards up past the water. And when the water starts to plug the pipe, now air is no longer able to flow past that water. And if you have a connection there, it plays havoc with the connection. So there are these connection restrictions. You can see there's an offset. On the top right there, you can see where a 110 pipe joins at a 90 degree or 87.5 degree angle. You've got a hatched section below there where you cannot join or make connections with waste pipes for the same reason, because they're going to the sewer is going to interfere with the waste pipe. And the same thing is at the foot of a stack. So at the bottom of a stack, the horizontal part of the stack or drain, if it's the foot of the stack, it becomes a drain at that point. And at the bottom part, the horizontal part of the drain, within 2.5 meters of the foot of that, you may not make a connection. So if these are to be followed, and often you need space, you need correct access to the drains, etc., etc. So there are another couple of reasons why ducts are necessary. So that's me talking about the requirements. I just want to show you a couple of pictures. What's the time? It's 20 past. Okay, so I think we're all right, Karim. So this set of pictures is a new development. Again, you can see my the time and date stamp on the pictures there. And what is it? One ground, 1, 2, 3. So it's a 4-story building. And you've got obviously sewer stacks all over the place because there's units all over the place, and not a stack in sight, not a duct in sight, not an access hatch in sight, nothing. How do the waste pipes join that stack? I don't know. Where do they join it? I don't know. Do they join under in the concrete first and then come out and join the stack once? I don't know. All you can see are these two little, well, dotted around this whole massive complex are these two little these discharge pipes as they come out. I don't know if that's from the ground floor toilet. I don't know if that's a stack. I seriously doubt it's a stack. I would expect that to be from a ground floor toilet, and it's totally inaccessible. That stack is just totally inaccessible, and it was signed off, and plans passed, plans approved. Some more examples of inaccessibility. You can see right at the top there is your vent valve, which is probably got an aperture of about 10 millimeters, and it's been painted with 6 coats of paint, and probably that aperture is now closed. So its effectiveness is questionable. And I just wanted to also remind us all about the purpose of venting. Now, obviously, I'm not talking about the obvious. The obvious thing is, yes, you need to ventilate because you don't want gargling and this and that. Yes, of course, that's a function of it. But let me ask you a question. How many of us see vent stacks protruding out of the middle of residential streets? As you drive down the road and you're on the pavement, every now and again, you see a big old stack, a vertical pipe with a big old vent on top. It doesn't happen. There are no such things. But yet the municipality has got hundreds and thousands of kilometers of sewage, which needs ventilation. You cannot have a buildup of this methane and this explosive gas. It needs to be vented. How do they vent it? Well, they vent it through the standards by telling us that the standards, by the standards telling us that we have to vent properly. We are their vents. Our houses are the vents for the municipal lines. So it's not just for us and for our individual property. So just because you can live with your gurgling bath, or the client can live with his gurgling bath, it doesn't make it okay. The ventilation is for municipal purposes as well as our own purposes. We are the municipality's vents. And so when they talk about at least one open vent from the highest point of the sewer system at each property, that's what the requirement is. So that does not suffice. And here's some more pictures of that wonderful installation with a wonderful design, should I say, with the stack inside the bedroom cupboards. There's multiple of these. There's dozens of them. It's just, there we go. So what are the consequences? This is the last slide. The consequences are having to demolish part of the building to access the pipe. Inability to pinpoint leaks or damage to pipes. What does that mean? Well, often if the thing is built inside of a wall, you see quite a big area of that wall start to discolor, start to become damp, and you don't know where to chop. You can try, you can chop somewhere, but I mean, 5 times out of 10, it's the wrong place, and you got to open up a bigger area. Now, I always draw an analogy like this. If I go to a brand new a Mercedes Benz or a BMW or a Kia dealership, and I say, I want this new Kia Sportage, please. And they say, wonderful choice, sir. Here are the keys, sign the papers, and you're about to drive out the door, and they say, by the way, You'll need to do periodic maintenance on those rear brakes. But unfortunately, for aesthetic purposes and the way that we've designed the fenders, what we'll have to do when we get to those brakes, we'll just have to cut away a little bit of those fenders. And but it's fine. We've got expert welders in our shop, and we'll just weld it back on. So I promise you won't see a thing. So that I'm just telling you, you'll probably have to do that within the next 60,000 kilometers. Who in their right mind will buy that car? Who in their right mind will design a car like that? And yet most houses are designed and bought like that. You're telling the client, oh, by the way, brand new shiny house, this nice wall, yeah, you're going to have to chop that pretty soon when the sewage blocks or when there's a leak. So, but it's fine. We've got expert plasterers, it's fine. Just chop your wall down and then we can access the pipe and then it's all good. Who in their right mind says that? Think about it, okay? So leaks damage the structure instead of being contained, because it's not being contained within a duct and discharged at the bottom of a duct. And it's the stresses, if the pipes are rigidly enclosed within a structure and there are stresses within that structure, it could damage the pipe just from the movement of the building itself. So what can we do? You can know your standards. What do the standards require? Okay, Mr. Architect, this is what the requirements are. This is what the consequences could be. Are you telling me, are you consciously instructing me to go ahead with this installation with having said all this? Okay, know your standards. You are the expert in the conversation, and discuss the requirements with all the necessary parties immediately you see the problem. What I mean by that is when you start to see it on the plans at the quoting phase, say, hey, where's the ducts here? Have that conversation then. Outline the consequences. Tell the owner, tell the client, hey, Mr. Client, do you know that this is designing a house to set you up for failure? And this is the reasons. And the more facts you know, the less you need to actually fight. You don't have to get into arguments. You simply state the facts and they can make up their own minds. And they can shout, scream, jump and shout as much as they like. The facts are the facts and these are the requirements. And you don't have to fight that. It's just the truth. All right, that's my story. And I don't know if there are any questions there, Karim.
Thank you very much, Richard, for this informative session. I believe there are no questions from my side. I'm going to go ahead and end the session now.